So now that we can create objective functions, and now that we can create the constraints that go with those constraints are going to be used to graph. And when we start graphing these functions now, we're going to do what we did earlier where we found corner points. Because in linear programming, the fundamental theorem says that if you want to minimize or maximize, which is the purpose of the objective to find the optimal solution, it always occurs at the corner points of the feasible region. So here's an example. I'm going to give you the following graph. I want to test to see which corner points maximize the objective function. Which one maximize the objective function? Well, the first thing I need to do is identify the corner points of the feasible region. Here's one at 0, 0. Here's another one at 0, 50. Here's another corner point at 30, 20. And here's another corner point at 40, 0. And so when I put these in a table, 0, 0, 0, 50, 30, 20, and 40, 0. What I want to do is I want to see which value maximizes the objective function. So here's your objective. They have an x and a y. Each corner point has a x and a y. So we're just going to plug in for x and y here. So if I plug in 0, 0, notice the value is going to be 0. If I plug in for 50, then I get z is equal to this times 0 plus this times 50. And so when I do that math there, I get this value, $450,000. Right? If I do the next one, I'll plug in 30 and 20. I get this value right here. $495,000. And then we'll do the last one, which is 40. I get this value right here, $420,000. So when I look at this, if my goal is to maximize, I want to know which point maximizes profit. Well, this point right here will maximize profit. And we're going to answer this in terms of whatever the problem is. We don't have any context here, but we would answer this as whenever you have 30 of whatever x is and 20 of whatever y is, that will maximize your profit. In this example, we want to minimize the profit. We want to minimize my profit. So I'm looking for the smallest value. But again, remember, in order to maximize or minimize, it always occurs at a corner point. So your corner points here are going to be the values. And it's just the corner points of the feasible region. So I'm interested in the point 1520, the point 272, and the point 4015. So these points are the ones that define the feasible region. Those define the feasible region. There are additional points, but we only care about the ones that define the feasible region. And so when I plug these in this time into the equation, I get 6 times 15 plus 3 times 20. And the value is this right here. The next one I'm going to get 6 times 2 plus 3 times 72. And I get this value right here. And then the final one, I'm going to do 6 times 40 plus 3 times 15. And I get this right here. If the goal is to minimize profit, then I want to look for the smallest value, and it turns out that this point right here is the value that minimizes your profit. So 15 of X and 20 of Y will minimize for us.